Alright, today we're going to talk about something called logarithms. And a logarithm it is another type of operation. So I want to write that down, that logarithms are an operation. Just like, addition, subtraction, square rooting, absolute values. Those are all operators that does something. Those operators do something to one or multiple numbers to get a new number, a new result. So a logarithm is just a new operator. And logarithms are also the inverses of exponential functions. So we're going to be using that idea of inverses when dealing with logarithms and exponential functions. So the definition of a log or logarithm we have right here that b and y be positive numbers where b is not equal to 1. The logarithm of y with base b is denoted by right here log base b of y. That's how you read that. Log base b of y. And it is defined as follows below. So log base b of y, if that equals some number x, then b to the x power equals whatever that y was. So you see you have the letters b, y, and x, and you have in log form, or the logarithm of log base b of y equals x, that can be rewritten as b to the x power equals y. So these are equivalent statements. Now a little bit of notation here. This little b, that is your base. That's the base of the log. Over here, that is the base of what is being raised to some power, some exponent. Now here, this x is your exponent. In the other form, the logarithm equals whatever the exponent is. Now this y, the term for that, I just call that the other number. There's probably a more precise word for it, but it's easier just to think of that as just the other number that we have. So over here, I kind of want to rewrite this, how to go from what's called log form to exponent form. So if we have log base b of some number y equals x, that is equivalent, and you can go back and forth from each of these forms. Oops. That is equivalent to b being raised to that x power equals y. So we can, like I said, we can go back and forth from the left side to the right side or the right side to the left side. So we can use logarithms or exponential forms to evaluate. Over here on the left, this is called log form because it has the word log in it. And over here, this is exponent form. Exponent form because it has an exponent. So down here, what we're going to do is we're going to rewrite some logarithms going from log form to exponent form and then exponent form to log form, just so that we understand how to convert. So this is log base b of 32 equals 5. So our base is 2. So I'm going to write 2. Now, the log equals your exponent. So on the left side we have the word log. On the other side we have 5. This 5 is your exponent. And then equals that other number, 32. And this is a true statement. 2 to the 5th power is 32. All right. Then we have log base 7 of 1 equals 0. So our base is 7. Our exponent is 0. And that will equal this other number, 1. And that's also true. Anything to the 0 power is 1. Right, next one we have log base 13 raised to the first power, and that equals the other number here, 13. Okay, that is also true. 13 to the first power is 13. Okay, so then we have another one. Our base is 1/2. So 1/2 raised to the -1 power equals this other number, 2. I'll just use the same color for consistency. And then we have our last one, 18 raised to the 0 power equals the other number, 1. And remember, anything to the 0 power is 1. So that's going from log form to exponent form. Now we'll go from exponent form to log form. So if we are in log form, it starts with the word log. Okay, and we say, what is our base? What number is being raised to some power? Well, that is 3. So log base 3 of 81 equals your exponent. Okay. Because your exponent here and the word log are supposed to be on opposite sides of your equation. So then we have log. Our base is 2 this time. Our exponent is our other number is 32, and it equals our exponent, 5. So then we have log. Our base is 15. Our other number is 15, and that equals our exponent, which is 1. All right, converting the log forms to the word log. Our base is 5. Our other number is 1, and it equals the exponent, which is 0. And then our last one, going to log form, we have the word log. Our base is 4. Our other number is 1/16, and that equals -2, the exponent. So we just did an exercise of converting from log form to exponent form, and then exponent form to log form. So now we're going to actually evaluate. You'll notice that all these logs right here, they equaled a number. What we're going to do is we need to figure out what that number is in these problems. Like, we don't know what this is equal to, so let's just make it equal x right now. And we want to figure out what that x is. So we're going to convert it from log form to exponent form. So 3 is our base, raised to the x power equals 81. Now from here, we're going to be doing this without a calculator. Well, how do we do that? We need to know our powers. Like, we need to know that 81 is 3 to the 4th power, because now the left side is 3 to the x, but instead of writing 81 as 81, we're going to write it as 3 to the 4th. These two are the same. Now, if our bases are the same, that means our exponents have to be the same, so x equals 4. So you do need to remember your powers. All right, letter B. And we're going to make this equal to x. And then 4 is our base to the x power equals 2, the other number. Okay, well now you might be saying, how can I rewrite 2 to have a base of 4? Like, we can't do that because 2 is smaller than 4. Well, remember, we can use negative exponents, we can use fractional exponents, which are the same thing as radicals. So 4 to the x, well, I can repackage this 2 as 4 to the 1/2 power. Right? Because the 1/2 power is the square root. The square root of 4 is 2. So now that the bases are the same, I can say x equals 1/2. All right, so this letter C, this equals x. And now we're going to have our base 1 over 4 raised to the x power is equal to 256. Okay, so I need to rearrange 256 to be like 1 over 4 raised to some power. Well, I know that 4 to the 4th power is 256. Okay. So we're almost there. I have 1 over 4 to the x equals 4 to the 4th. Now, I can put this 4 in the denominator by making this exponent negative. So I'm going to have 1/4 equals 1 over 4 to the negative 4th power. Oops, I forgot my x. Right, because remember, our rules of exponents say that I can move stuff to the other side of the fraction bar as long as I have our exponents correct. I can move this back up and get what I started with. So 1 to any power is 1. So now I can rewrite this 1 over 4 to the x power. Oops. I can rewrite that right, and this is equal to All right, now from here we can use our rules of exponents, and we want this 4 to go in the denominator. Well, we can do that by changing the exponent to a negative exponent. So we have 1 over 4 raised to the x equals 1 over 4 to the negative 4th power. So we're almost there. Now I can do this, bring it up like that, because 1 to any power is still 1. Oops. So now you can see our bases are the same, so our exponents must be the same as well. Yeah, so letter C was meant to be a little bit challenging, just to show you the powers of like how powerful logs can be, and being able to use logs in conjunction with the rules of exponents. All right, so I want you to try these 3 problems here, and then once you're done, unpause the video and check your answers. All right, so this these are the answers you should have gotten. And again, that middle one might have been more difficult because you had to deal with a negative exponent. These problems do require a bit of thinking because you're trying to get your bases the same. Like we're trying to make over here for this last solo problem, we want the bases to both be 16. Well, we can only do that if we change 4 into 16 to the 1/2 power. And we can do that again because the square root of 16 is 4. All right, so then on the next page, we'll briefly talk about the calculator. And you might be saying, well, can't I just use a calculator to evaluate these instead of doing all that work that we did? The problem is on your calculator, the log button is log base 10. These problems up here did not have a base 10, log base 7 of 49. If we just press the log button, there's an invisible 10 there that we don't see. So if we ever have a log with no base written, it's an invisible 10. And then we also have what's called the natural log, which is a log with the base of e, that natural number from the prior lesson. So example 3, we're just going to use our calculator to evaluate these. So if I do this and type in log of 1.234, so that's log base 10 of 1.234, and that is 0.09. It says round to the hundredth, so we can just do 0.09. Then the natural log, or ln, of 31.2. And that gives us 3.44. So we will learn how to use the calculators later to evaluate different logs, but I just want you to be aware that you can't just press log and type in these problems. All right, so the last example, and then I'm going to have you try some. We're going to go back to evaluating without a calculator. Now, it's going to be the same process as the previous page, so we'll do 81 to the x power equals 27. Now, you may look at that and say, well, 27 raised to no power is going to give us 81. Well, what if we changed both of these? What if we change 81 and 27? What if we change them to both have a base of 3? So again, we need to think hard and say, okay, what can I rewrite these as where they have the same base? 3 to the 4th power is equal to 81. And 3 to the 3rd power is 27. So I just repackage or rewrote what these are. Now the bases are the same, and then the exponents, remember our rules of exponents say if we have a power raised to a power, we can multiply the power. So we have 3 to the 4x equals 3 to the 3rd. Well, since the bases are the same, the exponents have to be the same, so 4x is equal to 3. And we divide both sides by 4, x is 3/4. Right, letter B, right, so that's equal to x. 16 to the x power equals 64. Converting it to exponent form. And then, what is the common base that we could use here? 16 and can be rewritten as 4 squared. And 64 can be written as 4 to the 3rd power. So we can multiply these exponents. So 4 to the 2x equals 4 to the 3rd. So 2x equals 3. And then we get x equals 3 over 2. Right, then letter C equals x. So we have 625 to the x power equals 5. This one's a little bit easier because 5 to some power is 625. So we don't have to do anything to the right side. We are going to change the left side here to 5 to the 4, 625 to 5 to the 4th power. And again, we can multiply these. So 5 to the 4x equals 5. Now, what is the exponent to just here, this 5? Well, it's an invisible 1. It's always an invisible 1 if we don't see anything. So we have our base is the same, so we can say 4x equals 1. Divide both sides by 4, x equals 1/4. Alright, so I want you to try these problems down here. Pause the video and try these. And once you're done, unpause it and see what you get. All right, so these are your answers along with the work. And again, the struggle is going to be if you know your powers or not. So you can use that power chart for a little bit, but you really need to be able to know your powers of 2, 3, 4, 5, and 6 and be able to recognize them and rewrite those in the bases that we have here. So, the more you practice these, obviously you'll get a little bit better each time. So if you need to rewatch the video, go ahead and do that, or rewatch parts of it until you have a little bit better understanding. So thanks for watching. Make sure to like the video and subscribe.